Hey everybody, so now let's look at another question which says the structure of 5 organic compounds A, B, C, D, E are shown. Answer the questions that follow. Each letter may be used once, more than once, or not at all, right? So you're given some fellows, and we've discussed this previously in the previous questions, that the way you need to go about such questions is you need to identify the families each compound belong to, right? That'll make things a lot easier for you guys, right? I do not want to go into the naming for each compound, but you just need to identify the family that each compound belongs to. So if you check A out, A has the carboxyl functional group, which is basically the COOH. Therefore, I could safely say that's my carboxylic acid, right? This belongs to my carboxylic acid family. If you check B out, B is just a saturated hydrocarbon, so we could safely say that's my alkane. Let's check C out. C has the functional group, which is the carbon-carbon double bond. Therefore, we know that it belongs to the family of alkenes, right? If you check D out, D has the OH group of atoms. That's the functional group. And from the functional group, we can identify their families, right? OH is basically known as the hydroxyl functional group. Who cares? Nobody cares, right? So it's basically my alcohol. If we check E, this fellow also has the COOH group of atoms, which is the carboxyl functional group. Therefore, this is also my carboxylic acid. Now, the only difference between A and E is that A is a 4-carbon carboxylic acid and E is a 3-carbon carboxylic acid. So a 4-carbon carboxylic acid is going to be called your meth-eth-pro-bute. That's butanoic acid, and that's propanoic acid. That's all we needed to know. Now it says, give the letter of the compound that is propan-1-ol. Right now, you could either do donkey work, or what you could do is you could do smart work. Donkey work would be that you start naming each and every compound, right? And smart work could be that if you just look at the naming, the name ends with an OL, right? Which means that this particular fellow belongs to the family of alcohols, and the only alcohol that you have in the list is D. So you could just write D here safely, yeah? Or if you still want to name it, I'll name it for you. So you select, how do you name compounds? You select the longest unbroken carbon chain. So that's meth, eth, prop. You select this and you write the name. And since it's an alcohol, because of the OH, you're going to write the name. So it's propanol, right? So, but between the propan and the OL, you're going to insert the number of carbon on which the functional group is present. Now, check this out. IUPAC says we start numbering from the side where the functional group is the closest. Since the OH is closest to the rightmost carbon, therefore we're going to start numbering from the right to we're going to go from right to left. And since the OH is on the first carbon, we're going to insert 1 right here. So yes, my dear fellows, this is propan-1-ol. Now it says give the letter of the compound that has an empirical formula of CH2. Now again, what you could do is you could write the molecular formula of each compound and then look for the simplest whole number ratio, which would give you the empirical formula. But if you are smart, you would know that CH2, if that's the empirical formula, it means it has no oxygen atoms whatsoever. So it can't be A, it can't be D, it can't be E. The only two options that you're left with is B or C. And now for B and C, I'll write the molecular formula, and then I'll see if it can further be simplified, right? Now for B, because it's a 3-carbon alkane, so I'll plug it in the general formula, which is C3H should be twice the number of carbon plus 2, that would be H8. Or what you could do is you could just count them up, right? And for alkenes, it's still a 3-carbon alkene. So if you have 3 carbons for alkenes, the hydrogens should be twice the number of carbons, right? So it's going to be C3H6. CnH2n is the general formula. Now, if you check the ratio between 3 and 8, it cannot be further simplified into whole numbers, right? But these 3 and 6 can further be simplified by dividing it by 3. So you're going to get 1:2. And this fellow right here is CH2, right? You have 1 carbon and it's present, and you have 2 hydrogens for every 1 carbon. That's the ratio. So what's the letter? The letter is C. C for salt. No, it's S for salt. Give the letter of one compound that reacts with bromine in an addition reaction. Which family undergoes an addition reaction? We know the alkenes undergo an addition reaction because of the carbon-carbon double bond. The double bond breaks and the new atoms are bonded where the double bond breaks. So that's basically C. So let's put the letter C once again. Now it says give the letter of one compound that reacts with chlorine to form a compound shown. And if you can see this, a hydrogen atom has been substituted for a chlorine atom, which means that a substitution reaction should have taken place. And we know that alkanes undergo substitution reaction, and in the list, if you check the list out, you only have B as your alkane, so you could safely just insert B here. Although if you wanted to confirm that it's propane, you could safely say that since it's a 3-carbon haloalkane, it must have been made from a 3-carbon alkane, which is obviously once again propane, right? It would react with chlorine. A chlorine atom has substituted this hydrogen on the middle carbon, and that's why you end up with a 2-chloropropane, and HCl is going to form, right? White steamy fumes, who cares? Then it says, give letters of two compounds that can react with each other to form an ester. How do you make an ester? For an ester to form, you need to have a carboxylic acid reacting with alcohol. And obviously we provide certain conditions, which is we use an acid, inorganic acid, usually sulfuric acid, conc sulfuric acid, concentrated H2SO4, and we heat it till like 200 degrees Celsius, right? So you have to check your list, and you have to select an alcohol and a carboxylic acid. Now we only have one alcohol here, D, so I'm going to plug in D right here, and you can either take A or E. It's totally your choice, because A is also an acid and E is also an acid, unless the question specified that you need a 3-carbon acid or a 4-carbon acid. Since no such specification is given, you can take either A, or you could take the fellow at the bottom, which is E. So A or E, both would be correct. Now it says, give the letter of the compound that is in the same homologous series, which means that is in the same family as hex 1-ene. It ends with an E, which means this fellow right here is an alkene. So you need to select an alkene from the list, which is once again C. Too many C's, right? And those of you who get confused, oh my god, C is coming so many times, the examiner has specified it himself that each letter may be used once, more than once, or not at all, right? Now it says, give the letter of one compound that's an acid. So you have two acids here. You have butanoic acid, meth, eth, prop, but. That's my butanoic acid, and that's meth, eth, prop. That's propanoic acid. So you can either take this fellow right here, which is A, or you could take this letter right here, which is E. So A or E, either or would be correct. That's A, or you could also say E. And that's pretty much it. These questions reiterate your entire organic chemistry concepts, and they help you revise these concepts, and therefore you can watch these videos. These are 10-minute shorts that I'm making to be uploaded on the YouTube channel, so that you could watch them right before your paper, so it helps you out. And yeah, that's pretty much it. See you guys in the next bit. Bye bye, ciao, Allah Hafiz, bye peeps.